Good evening to everyone and welcome to our webinar, Unveiling the Inner Workings of 3D Printers, a short dive into printer parts and components. I'm Ioana Donova from VAEF, and together with my colleague Marco Ru, will be your host for this webinar about 3D printing. This webinar is not just about the nuts and bolts for 3D printers, though we'll definitely get into that. It's also about education, innovation, and the future. Today's event is part of the project 3D4AUTO, which stands for EACEA, Compatible 3D Printing Training Modules for Automotive Technologies. This project was developed within the framework of Erasmus Plus program. Participating countries are Slovakia, Bulgaria, Portugal, Austria, Greece, Turkey, and Italy. My colleague Marco will explain a bit more about the project now.
Yes, thank you, Ioana. I'll share my screen. So I'm just going to describe a little bit the project, as my colleague mentioned. This is a project funded under the Erasmus Plus umbrella. It's a project that aims to finalize in November of this year, 2023. The aim of the project is to implement and develop a 3D printing and prototyping course, especially directed for high school students in the automotive technology sectors. Some of the objectives of the project are to stimulate the creativity of students and the potential school laboratories for 3D printing, and to introduce 3D printing technologies into high school students. Some of the results of the project are a base 3D printing curriculum and training modules that we created among partners. As Joanna mentioned, this is a project with 6 different partners, coordinated by Slovenia and participating from Austria, Portugal, Italy, Turkey, and Greece. All the material has been translated into the 6 different languages and English, so 7 languages in total. There is a mobile hub that was created with different learning units to get closer or more acquainted with 3D printing technologies. This includes supporting material such as virtual trainings and seminars like this one, and policy recommendation reports. There are 7 units in this e-learning course in our website. The first one is the Introduction to 3D Printing Technologies in Automotive Education. And this intends to bring students closer to 3D technologies, to inform them about the possibilities of 3D printing, and specifically for automotive practices. The second one is on 3D printed parts, which is the unit that we will focus our webinar today with my colleagues Fabio, Ben, and Daniel. And the idea of this unit is to learn more about the different components and the elements of 3D printing parts and their specific functions. We will get more deep into this in a bit. The third unit is the creation in virtual environments, virtual objects in virtual environments. And we will learn on-shape software for this. And the idea is to teach students on how to apply the drawing techniques in 3D objects, and to convert 3D objects to STL files, among other things. The fourth one is slicing techniques, and for this, you will learn different processes of slicing, and the module also aims to explain the creation of slice geometry. The fifth module or unit is using techniques of the 3D printer. Sorry. And for this, the aim of the module is to learn more about the important techniques used in 3D printings nowadays. For example, liquid-based printing, power-based printing, extrusion-based printing, etc. Most of the units are vary from 3 to 5 hours, because they include a technical part, a training part, not just theory. The 6th unit is 3D printing materials, and this is to identifying the most popular materials used currently, and what are some of the challenges for each one of them, their applications, the distinct diverse characteristics, and so on. What are the pros and cons of each material? And again, for learners to be more aware of the possibilities of 3D printing. The seventh unit is sample STL codes for automotive technology in education. And this module focuses on the use of coding for 3D printing, and specifically for automotive models. Again, we will understand its application and the importance of STL coding, especially for creating printed materials. Basically, that is the modules. Those are the modules that we created for the hub, the learning hub. Please learn more about them in our website that we will share in the chat and also about in the project website. And yeah, now we can go dive deep into the printer parts.
Thank you, Marco, for the summary of the project. For this webinar, we invited 3 experts in the field of 3D printing. Daniel Grasser will talk about 3D printer parts. Fabio Rezzi will talk about 3D printers and application in the automotive industry. And Sven Urimov will talk about machine electronics, slicer software, and 3D geometry creation.
So my name is Fabio Rezzi. I'm a student of mechanical engineering. I was first introduced to the world of 3D printers in high school, where as a part of a robotics team, we were producing parts for our robots. And ever since then, I have developed myself as a hobbyist and as well used it further in my curriculum and university projects. Before my colleagues go into details about parts and softwares for 3D printers, I would like to give an overview how it can be beneficial to the automotive industry. This technology, also known as additive manufacturing, has already started to change the way we create products and holds the key to changing various industries. Further, we will explore the basics of 3D printing and how it can be beneficial in automotive manufacturing. First, let's define 3D printing. It's an additive manufacturing process that constructs objects layer by layer. Think of it as a precise digital sculptor turning a design on a computer screen into a real object. This layer-by-layer construction is at the heart of 3D printing for all different methods, such as fused deposition modeling, SLS, known as selective laser sintering, or stereolithography. The possibilities of this technology are numerous, and it has a potential to revolutionize traditional manufacturing process. As far as the automotive industry is concerned, the impact of 3D printing is very profound. The automotive sector is expected to experience a transformation thanks to this technology. One of the key advantages is rapid prototyping. Automotive engineers can now quickly create and test parts. This not only speeds up the development process, but also reduces associated costs, allowing for more design iterations and innovation. Functional testing is paramount in the automotive industry, and thanks to rapid prototyping, it is easier to approach. 3D printed prototypes can undergo rigorous testing, ensuring that designs are robust and safe, thus minimizing flaws and enhancing reliability. This also brings down the cost associated with prototyping and testing, which usually are high with conventional methods. This technology allows for the production of intricate and complex part geometries. This is invaluable in automotive manufacturing, where lightweight is a priority for improving efficiency and reducing emissions. 3D printing also allows for the production of custom automotive components. This is particularly relevant for the production of high-end customized vehicles, as well as in creating aftermarket parts. As we look to the future, 3D printing in the automotive industry will continue to advance. With improvements in technology and materials and increasing adoption, the power of 3D printing will reshape the automotive manufacturing landscape. I would like to close this, and I would love to give the word to Daniel to further speak about the building parts of a 3D printer. Thank you.
So, Daniel, because you said that you have a problem,
Yeah.
I
It would
will
be great if you
share.
could share. Yes, thank you.
Perfect.
Okay, so I'll be explaining pretty much how the fused deposition modeling works, This type of 3D printing, basically in this type of 3D printing, we have a filament that gets heated first and then gets extruded onto our printing bed. And in this way, we can get our 3D print. The first part I'm going to talk about is the extruder, right at the top.
I'll actually help with that thing. Just let me, because I don't have a pointer, I decided just to use the actual machine.
Okay, perfect.
And something a bit more interactive, you know.
Okay, perfect.
So here you can see the extruder coming down, if I had to guess. Yeah. So yeah, exactly. Here you can see the printing bed on the bottom, and it's moving in the y-axis, which is usually not common. Usually you'll only have the printing bed moving in the z-axis, and the extruder itself moving in the x and y. What it means is the extruder moves on a horizontal plane while the printing bed itself adjusts itself vertically. So yeah, you can see here the parts. You have the motherboard, you have the extruder, you have the wires and some filament, as well as the printing bed. Exactly.
So which part should I point to first?
You can please point first to the printing bed. I think that's pretty obvious what it is.
Self-explanatory. Yes, the printing bed actually takes up the whole shape of the printer.
Yeah, exactly. Can you say what it's made out of in this case?
Well, particularly this printing bed is made out of steel. Usually the printing bed is a big plate, usually aluminum, with a big heater on it, under it mostly. So it can actually heat up the material so it can stick. The surface of the print bed is actually coated with a sheet of PEI plastic, which is a thermoplastic which doesn't actually melt, but gets really sticky once it reaches around 60 degrees.
Right, perfect. I guess I will first go through the different points before actually showing it. I think that might be better. So, Jan, if you could please go back to the presentation itself. So I'll go through the points, and then maybe it's easier if I afterwards show the picture so it becomes clearer.
Of course. You see this right now?
Yeah. Could we maybe like cut this out and I start again, because I feel like it will be a little bit confusing now, the whole thing. Is it possible?
Yeah, just
okay, cool. I'll go from the start. My name is Daniel. I'm a mechanical engineering student at the Technical University of Vienna. I had my first contact with 3D printing when I was in the former student team building race cars and was building printing parts for our battery pack. I got some more experience later when I did the LTTA last year in Portugal. And yeah, I'll be presenting the 3D printer parts now. The first part I'll be presenting is the extruder. The extruder is pretty much made up of the hot end, the cold end, and the nozzle. The filament comes in through the cold end and gets passed on afterwards to the hot end, which heats up the filament with a resistor, with a resistance. This resistor has electrical current going through it. That part gets transformed into heat, which heats up the filament, and then through the liquid form, it can come out of the nozzle and be printed on our printing bed. As far for the printing bed, it can be made out of plastic, aluminum, glass, or even steel in some cases. Printing beds can be split in heated or not heated. Heated printing beds are good to help with adhesion. So when you're printing in the beginning, you want to make sure that your first layer that you print is it's stable, so it doesn't trigger make the print less accurate. So in the beginning it's heated, and later you want it to get colder because you don't want the 3D printed part to be sticking on a printing bed. Exactly. For the hot end, yeah, as I said, it gets sorry, could you go up? Yeah. It's the filament gets heated in the hot end through our heater, which is a resistor, the heater cartridge. The potency will usually go from 25 to 50 watts, but you can also get higher potencies if you need more heat. The maximum heat you can get, the maximum potency would be 80 watts in some specific heater cartridges. And yeah, in the nozzle. Okay, yeah. No, can you go up a little bit? Yeah, exactly. In the extruder, you can have two different types of. In the hot end, you can have different types of extruders. You can have the direct extruder, which directly connects the hot end and the cold end. This can be sometimes problematic because you can have some of the filament staying back at the nozzle and in this way damaging the heat cartridge. Or you can have the bottom extruder, which has a filament, a tube connecting the cold and the hot end, and in this way it's safer for the whole process. If you could please go on. Yeah. Going to the filaments, mostly the filaments that we use will be polymers, or yeah, we can also use metals or wood in some specific cases, but those require specific printers and are way more expensive. So usually we'll be just using polymers. The most used ones are ABS, which stands for acrylonitrile butadiene styrene, which has a lower heating point. We can, by 180 to 230 degrees Celsius, it already starts melting. And the other one is the PLA, which stands for polylactic acid, which has a higher heating, a smelting point from 210 to 250 degrees Celsius. It's way tougher than the ABS. It causes less jams because the ABS itself requires a heated printing bed so that it doesn't stick or doesn't have any deformation. And on top of that, the ABS, when you heat it, it really smells bad. So usually you will see the PLA being used more as well. Yeah, it's biodegradable as well, which is like good for the environment. So yeah, if you could please go on now. Right. Yeah, the next point we'll be putting together the whole mechanical part, which includes the gears, the stepper motor, the belts, the screws. So pretty much you'll have a motor which propels the belt at a constant speed. So you can have it's very important for the printing process to have the same deposition of material in every part. So you want a constant speed, and we can achieve this through the stepper motor. It propels the belts on in the X and Y axis, and as well as the Z axis. And through them, we get like a accurate print. If you could maybe go down a little bit more. Right, the heater cartridges we already covered. They can go from 25 to 50 watts usually, sometimes being higher or lower. The thermistor, the whole printing process, it's very important to keep the heat levels at the point you want them. And we measure this through the thermistor. It's an electrical device that's connected in multiple parts of the 3D printers. Depends which one we have. In our case, it will be usually connected to the nozzle and the printing bed. In the printing bed, it's between the printing bed itself, and if you have a heated printed bed, the heat source. And in the nozzle, you will have it connected through a wire. Exactly. Yeah. Now we have sorry, I think you went down a little bit too much there, Joanna. Yeah, exactly. We have the nozzle now. The nozzle is the part which, as I said, where the liquid filament comes out. The three most important measures there are the size, the material, and the inner diameter. A bigger nozzle, of course, will have a bigger surface area just because the volume is bigger and can transfer more heat to the filament to heat it up, which is beneficial because you speed up the whole process with this. Then the next part is the material. Different materials will have different thermal coefficients, so you will have to see what is ideal for you for the printing process. And last but not least, in a diameter, if you have a bigger diameter, you can have a bigger flow, which increases the speed at which you can print. But on the downside, you will also have less accuracy because you're just coming out with a bigger diameter in your liquid filament. Yeah. So the next point then will be the cooling fans, of course, to keep the whole printer in check, to not overheat. You will have cooling fans, which will be in different parts of the printer. You will usually have one between the hot and the cold end so that it doesn't, well, you want the cold end to not heat up, as well as the power supply, because of course you have electrical current going through, which heats up. The motor control board, the motor, as well as the control board, will also need a cooling fan to keep the temperature in check. So yeah, that's this. Then next we will discuss the X, Y, and Z axis. You have a Cartesian scheme in the 3D printer, which we know from school perfectly well. The extrude itself will usually move in the X and Y axis, as you can see in the video right now. And the printing bed will usually only move in the Z axis in most printers. In Sven's case, my colleague, you will see that his printing bed can also move in the X and Y axis. Of course, if you take more elaborate printers, more expensive equipment, you will have specific axes that are created an X and Y axis or YZ axis, which then will allow you to get to different points of your 3D print. Exactly. Then next, if we have a printer, we of course want the print to be on the printing bed and not go beyond. So we introduce small electrical components which are called end stops. They limit the whole printer in the X, Y, and Z axis. And yeah. Then the next point are both the lead screws and the belts. They are connected through the stepper motor, and they allow us to, as said before, to keep a constant speed when we're printing, which is super important so that we get an accurate print. The belts, they can both be positioned in the Y and X, Y, and Z axis to get us the range of motion that we need. So going further down, we will now get to the electrical components, which Sven will be presenting. Before that, I would like you to, Joanna, if you could maybe pin Sven's camera, that would be great. Yeah. Here you can see some of the parts that I talked about. You have the extruder. If you could please point to it, Sven.
Just give me a second. Which part of the extruder?
Extruder, yes. Could you please point to it? Yeah, it's moving here, as you can see. Then on the bottom, you will see the printing bed where all the components are laid upon. In the lower left, you can see what looks like the motherboard in this case. Above that, you will have. Is that a second extruder you have up there, Sven?
No, that's actually the heating cartridge by itself in a thermistor.
Okay, yeah, you can see the heating cartridge there. To the right, is this a motor, or what do we have there?
Bottom right, that's actually a stepper motor, which
that's the motor, exactly.
To add it. Let's actually showcase it.
Yes.
That thing is called a stepper motor. It basically is a motor that takes steps. It doesn't spin freely altogether. It just makes 1.8 degrees steps each time a signal is passed through it.
Perfect, yes. Then on the top there, you can see the filament, which in this case, what material do you have here for the filament?
This material is actually ABS.
Okay, great. Yeah, you have the ABS, as I talked about before. And yeah, I can't really tell from the image what is below it.
Below it, oh, you're talking about the motherboard.
No. The red and black cables, and right next to it is something, but I can't tell really.
This thing.
Yes.
That's actually a thermistor.
Oh, okay, that's the thermistor. Perfect. Yeah. So here you can see the thermistor, which helps you control the temperature of all the single parts in the 3D printer. And yeah, I think I went through all of them now, right?
I think, yeah.
Okay, perfect. Thank you, Sven.
No worries.
For the next part, the electrical components, I will now pass on to Sven, which will explain the power supply, the motor, the motherboard, and others. So yes, thank you.
Well, it's my turn. Okay, so basically, in the end of the day, what exactly is a 3D printer? A 3D printer is basically a triaxial coordination machine that moves in 3 axes, X, Y, and Z. And to the end of it, it's basically a hot glue gun, which just squirts hot glue everywhere. And that hot glue is called filament. So in the simple terms of the matter, it's just a hot glue gun on a very expensive coordination machine. So let's actually get into the electronics part and how the hell these things work. So if I actually move my camera, give me just a second because I'm just doing it manually, right? So let's first off with the motherboard. Why is it the motherboard? Well, because everything actually starts from it. That motherboard is basically connected to a 12 or 24 volts power supply, which basically looks something like this, a standard power supply. So after it's connected, it actually uses these little things that are called stepper drivers to drive a coordinated assembly of stepper motors that actually drive the belts that drive the other stuff that make the printer move. So the big question is, how does it do that? So if you see this little thing right here, this little thing right here, that's called a stepper motor driver. It basically has 4 poles. it passes current through each pole, each step it takes. So you send a binary code, or basically just press a switch 1 time, 2 times, 3 times, 4 times. Every time the switch is pressed, the poles of the stepper motor change their polarity, thus making the stepper motor, which is to the right of where I'm pointing, move 1.8 degrees. That actually makes a turning motion inside the, what was it called? Oh yeah, the belt. Yes, the belt, which drives the axis. So the other question is, how does everything work together? So for that, I'll actually showcase my screen just for a little sec. Share screen. And okay, there we go. So this is basically my interface. These are called G-code files. G-code files is basically a short naming for Go files. It's just a string of code that says go somewhere, do this thing. So if I write G1X, for instance, 100 with a speed of like 30, okay, nothing happens, but still it's supposed to go to X100. And the reason why nothing happens is because I'm already at that 100. But if I write it again, it's basically supposed to, come on. Okay, it's moving somewhere. So overall, you use this coordination system to point the machine where it's supposed to go, what it's supposed to do. But for that, we actually need to have the G-code prepared. So what's the whole process of preparing a 3D object from virtual space into G-code, telling the machine where to go for it to make it? We use this thing called a slicer. A slicer is basically a program that gets a 3D object and slices it into different layers, each layer with a height of 0.2 or whatever you set it at. After that, it creates a shape around the object, basically everywhere where the light hits, and somewhere that it even doesn't, and creates a trace around the object with the perimeter of the actual object. After that, it basically decodes it into G-code and tells the printer, move along this path, do this thing, and while you're doing it, extrude a little bit of filament. So the hot glue gun just starts squirting out hot glue layer after layer, making one layer on top of another and rapidly cooling it so it can basically create a shape. If you can imagine an actual hot glue gun doing it, it would be very not precise. But because these are 3D printers, after all, people have basically learned how they can make it precise. So for that, let's actually download an STL object, which is the standard format for 3D objects that can be converted into G-code files. Just give me a second. You click download. And we loaded up our file. Is my screen sharing okay? Yes, no?
Yes, we can
Yes,
see. We
it's
can
working.
see.
Yes, it's good.
Okay, perfect. So let me just hide this window away. Okay, there we go. So in the 3D space, we basically have an object. That object can be pre-made by somebody else from sites that are called model sites. The most popular one is called Thingiverse. It's open source. Everything on it is free. So I just downloaded this cube from it and just dragged and dropped it inside of my slicer. Now I can basically reshape it, scale it. Let's actually make a bigger cube like this and even flatten out. We can basically play as much as we want with our pre-made STL objects. So after that, I can actually go into details saying what every single thing of these does. But for that, honestly, I just have presets that I can make one time, and just, if I decide, click slice plate, and boom. The object has been sliced into different layers. If you can actually see the layers right here, do you see how there's little bit layers? These are actually the G-code coordinates where the printer will go. If I start doing the simulation, I can actually see how my nozzle will travel along these paths. Well, backwards. And basically, on the right side, we can see the G-code. For instance, this G1, which basically means go somewhere, X coordinate, Y coordinate, extrude coordinate, because extrude is also a coordinate, and just continue doing it until layer after layer, until we have a solid object. And if we actually go back into the slicer view, we can actually downgrade the object to see how each layer is formed. So on the basis of it, you start layer after layer, building on top of each other, creating a solid object from quite literally hot glue at this point. But hey, that's filament for you. So we basically got down how you could slice objects, but people, especially engineers like us, aren't really happy with making somebody else's work, right? So thus, we actually got into the 3D printing, well, not 3D printing, 3D building software. A popular one of my personal choice is called Fusion 360. Question is Fusion 360 shown? Is it? Am I sharing my screen, or am I sharing only the program?
The program.
Okay, so if I click stop sharing and I share again.
Now we see the extruder.
What?
Now we see the 3D printer.
Yes. Now we get into Fusion 360. So this is the most basic, well, honestly, not most basic, but most industry standard program you can get on the market. The principle of it is, of working, is basically you create two-dimensional sketches, like so. For instance, let's create this shape. Let's do one cross here and here. After that, I've created my two-dimensional shape. I finished the sketch, click the planes I'm interested in it, and hit extrude. Boom, we just made a 3D object into 3D space. So, big question is, after we do this, after we do a lot of stuff like creating different planes, maybe derivatives from planes, let's actually create a cut right here, like so. Come on. Finish sketch. Hide my body for a second. Enable my bodies. Click extrude. Cut a portion of it. And this way we can basically make 3D shapes with this program. So the question is, how do we get the object out of the program and into the 3D printer? That is done by basically selecting the actual body of the object. Let's say we want this part 3D printed. We right click on it and we click Save as Mesh. It does some magic calculation, and at the end of the day, you have a 3D printed file. Save as. Oh wait, let me actually showcase the mesh before everything, for you to actually know what a mesh looks like. So if we click preview mesh, we can see a bunch of little dots. These little dots basically intertwine or make vectors from each other to create a one-dimensional plane. If you have a second intersecting dot, or basically a triangle, that's why we call mesh triangle vectoring. That way you can create a plane, stack up enough planes on top of each other, and you have a three-dimensional object. So basically, one dimension is the actual line, the second dimension is a cross between two lines, the third dimension is a cross between three lines, thus 3 dimensions. So let's actually get this object. Save it. Forget where we saved it. Do it again. Oh yeah, that's where we saved it. Downloads. Okay, so going back to my neat little program here. Let me just screen again. We basically got bored of this cube right here. So let's just delete it by pressing delete. Get our body, drag and drop it, and boom, we have it. We click slice. Our body is sliced. We select our printer. We select our material, which is currently PLA. We select the standard, which basically defines how tall are my layers, because I can slice 0.2 layer, but I can slice a 1 millimeter high layer, which is going to be really low quality. But because we're working with technologies nowadays, we can integrate our printers to such a manner that we can basically hit print, but we have to remember something before that. Let me just switch back to my camera. Okay, so right now you can see that my plate is filled with stuff. So in a way, let me actually clear it. Okay, we set the coordinates to here. And a fun little thing that I like to do is basically, where's my acceleration? I forgot why my acceleration was. Just give me a second. Restart my system real quick. Okay. Okay. So basically, remove this thing here. We go back to our slicer. We just find the slicer. Oh yeah, there it is. We go back to our slicer. We've already sliced that object. We inspect it. All's good. And we just hit the print button. And that's how easy it is to actually get a 3D object from virtual space into your printer. Right now, this object, as you can see, my printer is going to go faster. It's going to calibrate itself. And it's actually going to start heating up with that cartridge that Danielle told you about, which basically heats up the end of the hot end, that's called hot end, and starts melting plastic one layer after another. But it's going to take some time for it to actually start up, because right now it's currently at 29 degrees going to 30, and we have to reach a temperature of 54 degrees. So while that's printing, I can say a bit more about how the inside electronics work, even though I mostly said everything about it. Any questions?
No, it
Yes,
was very
actually,
clear.
I
Okay.
okay.
No, sorry.
Yeah, I would like to ask which mechanism is actually heating inside the printer.
Um,
Uh,
should I answer it or do you want to answer it, Sven?
be my guest.
So, as I said before, you have a heating cartridge, and if you know about electronics, if you have a resistor, it gets electrical current to go through it, and it loses a little bit of the voltage through it. And this energy gets turned into heat. Like electrical energy turns into heat, and this heat heats up the filament, which then liquefies.
We can actually cold start the cartridge right now if you want, so we can actually show the process of it.
Oh, okay.
So if you look at my camera, real quick.
Can you maybe stop sharing the screen so we can see the
Oh yeah,
camera better?
perfect. Just give me 1 second. Okay, stop sharing. So basically, let me just remove this pencil. Where is it? This little thingamabob here. That's the heating cartridge we're talking about. Inside of it, it has a resistance coil which passes electricity. That electricity creates inductance and in the end heat. So let's actually start it up. See how it works. Set my amps. Okay, there we go. And at some point we are gonna probably see smoke. Or something blows up. Actually turn this off.
I think it's better with the lights on.
Oh yeah, it started to actually smoke.
Yeah, we see it.
Right, currently we're actually pushing around 3 amperes of electricity throughout this heating cartridge. It started to glow. Let's turn up heat. Okay, there we go, more smoking.
Yeah, it's a little bit hard to see through the video.
And the actual printer has actually started to print. Turn it off, no. Well, apparently we don't have a glow right now. Even though, oh, wait, that's why we don't have a glow, because we're at, okay, there we go. There we go. Now we do have a glow. And at some point, I'm gonna have to turn it on before I actually burn my fingers. So yeah, that's how the heating cartridge works. And wow, it's actually still going.
Don't burn your fingers, please.
Ah, don't worry, I'm a little bit crazy. But yes, the printer is actually going and started to print that object we told it to print through the program. Really easy peasy. Okay, any more questions?
I think we don't have questions, but maybe you want to stop it if you really don't need that part printed.
It's no worries. Let's actually, like, a common misconception that everybody currently thinks is that 3D printers run extremely slow, because Well, most people think that this part is gonna take around 10 hours. But for me to actually personally prove them wrong, let's set the speeds of the printer to actually around 200 and watch it go crazy just for fun. %. Which means I'll have my part finished in 19 minutes. As Fabio was actually talking about that in the beginning, manufacturing of test parts for vehicles is actually a very costly process. Most parts nowadays are done with injection molding, and injection molding actually requires you to make a mold. That mold costs, the most basic molds that actually cost minimum $5,000. So for you to make a mold to create a test part, and then only when the test part is finished, actually realize that it's broken or incorrect, that is something very costly.
So you can print with metal as well.
Yes, that's what selective laser or selective layer sintering is. The whole process of printing with metal is actually a layer of powder that's being melted by a very hot laser, and after it's done melting, another layer of powder is basically sprinkled on top of it. Let's actually cancel this print right now.
Yes, I think it went too crazy when you put it for 300.
Probably.
Great, thank you very much, Sven. And thank you very much,
We
Danya
still
and
have
Jesse, as well,
this
for
little part here right now. Done in a couple of minutes.
your explanations. It was very interesting. I hope that learners also are able to also in the future, because it's going to be recorded and uploaded in the hub, are able to learn more. I certainly did about 3D printing. Thank you again, and for our learners, please check out our website at 3D4AUTO.eu, and there is the hub where you can take the free modules, free classes, online in a self-paced manner. And yeah, thank you again, everyone, for your time and for being here, and especially to Jesse, Dalio, and Sven.
Thank you for the invitation.
Okay, thank you.
Good to see you again.
Thanks, guys.
Thank you.
Well,
Thank you.
bye.
Bye.
Goodbye.
Bye.
Bye.
Bye.